Hi guys, today we're going to talk about geometry. The standard associated with this concept is 8G1, verify experimentally the properties of rotations, reflections, and translations. Lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure. And parallel lines are taken to parallel lines. That's a lot of words, but we're going to break it down like we always do. So your learning targets. I will know vocabulary and notation related to rigid motions. I will use transparencies to imitate a rigid motion that moves or maps one figure to another figure in the plane. So we're going to look at some vocabulary to help you get ready for this lesson. And in the lesson, we're going to be talking about rigid motions. Right now, I'm just going to do an overview to get you ready for this lesson and prepared. So our vocabulary, we have area. Area is the size of the surface. So all of these have the same area. They all have 9 squares, so they all have the same area. No matter how you put these together, they have the same area because they all have 9 squares. The perimeter is the distance around the shape. So this is 5 inches, this is 3 inches, this is 5 inches, and this is 3 inches. So to find the perimeter, we just add 5, 3, 5, and 3. We just want to know what the distance is around this particular shape. Parallel lines. Parallel lines are the same distance apart and they never meet. So, like the lines you see on the road, those are parallel lines. They will go on, but they will never cross each other. And they have the same distance between them. Opposite of parallel lines are perpendicular lines, lines that intersect. So they are going to touch each other. They at an angle of 90 degrees. Remember, our 90 degrees looks like our chair here. We have 90 degrees, so it's straight up here and horizontally right here. So the lines actually meet right here at this 90 degrees. You have seen it with the telephone poles. You can see the perpendicular lines right here. They meet at that 90-degree angle. So we can put our chair right there. A ray is a part of a line that starts at a specific point. So it has an endpoint, and then it extends endlessly in one direction. So see how this arrow is showing that it's just going to keep going and going and going. You've seen a ray with a flashlight. It starts here at the flashlight and keeps going and going and going. A line segment is a part of a line that has 2 endpoints. So unlike a ray, it starts here and ends here. So the ray started at this specific point and then it kept going. But a line segment starts at this specific point and ends at a specific point. An angle is a figure formed by 2 rays. So you can see your rays here. So it starts here and then it goes out, and then this one starts here and goes out. And what is in the middle right here is your angle. So an angle has to have this common point right here. There are different types of angles. So there are supplementary angles. So these 2 angles, remember, they share an endpoint. So this ray and this ray makes an angle right here. And then this ray right here and this ray right here makes this angle. So in order for them to be supplementary, this angle right here and this angle right here have to add up to 180 degrees. Complementary angles, remember, are two rays, so we have a ray here and a ray here. Here's our angle right here. Then we have a ray here and a ray here. Here's our angle right here. So they have to, these two angles, this angle and this angle, have to add up to 90 degrees to be complementary. Vertical angles. They're one of two opposite and equal angles formed by the intersection of two lines. So we have an angle 1 here, we have angle 1 here, angle 2 here, angle 3 here, angle 4 here. For them to be vertical, they have to be opposite. So our two opposites, we have angle 1. The opposite of angle 1 is angle 3. The opposite of angle 2 is angle 4. So angles 1 and 3 are vertical, and then angles 2 and 4 are vertical because they're opposite. So this angle, angle 1 right here, is the same as angle 3. If they're opposite, they're equal. Angle 2 and angle 4 are the same because they're opposite. If they're opposite and equal, they're vertical angles. So that's going to help you later on. So if they're vertical angles, they are equal. Adjacent angles is our next one. These are two angles that have a common side and a common vertex, corner point, and do not overlap. Okay, so this angle right here is angle 1, then we have angle 2. So these two angles share this side right here, this C right here, this ray from B to C, line segment from B to C. So these angles aren't overlapping, they're not on top of each other. And they have that common side and vertex. That's what makes it adjacent. Triangles. Triangles have 3 edges, 3 vertices. So in here, our picture, you will see the different types of triangles. We have acute triangles that have an acute side, have all acute angles. A right triangle that has the right angle inside of it. Obtuse has an obtuse triangle, that means it's more than 90 degrees. Our isosceles triangle, that has 2 sides that are the same. The third side is not the same, but it has to have 2 sides the same to make it isosceles. Equilateral triangle, all of the sides are the same. And then our scalene triangle, where none of the sides are the same. Quadrilaterals have 4 sides. They have 4 straight sides. So we have our square, rectangle, parallelogram, rhombus, trapezoid. This is nothing special, it just has 4 sides. And then our kite. See, these are types of quadrilaterals because they have 4 sides and 4 straight lines. So what I want you to ponder before you go to class is, how do we find out if these angles are the same, if these lengths of sides are the same, if these 2 line segments are the same, without getting out a ruler and measuring them? How are we going to figure this out? This is something I want you to ponder before class. Think about it. How are you going to figure out if they're equal, if they're the same, if you don't have a ruler or a protractor to measure it? Okay, watch this video as many times as you need, and I'll see you in class.